And in your warm-up for buggy buttons, you are going to find and fix 3 errors in the program. You should look at the question text. It should be perfectly centered to the window. Each button's text should be perfectly centered to the button. And that will be 3 errors in there. I'll give you guys a couple of minutes to work through that. And remember your different attributes. Not only do you have the ability to put specific XY coordinates, but you also have the ability to align things centered, left, right. Raise your hand if you still need a little bit more time on it. Okay? Don't forget the order of your arguments in your inside the parentheses. So you have the font height, you have the XY coordinates, you have the width of your text box, and then you have the actual text that goes in your text box. Okay, who's been able to get the text up at the top of the screen so far to where it's moved to fill the width of it? No one has? I see one person has. Okay, so you want to share how you did that? Okay, so yeah, so remember that your text label, or I shouldn't say your text label, your window has a width of 1,018 pixels. So she basically just rounded it to 1,000. That is one way of doing it. Now, you also have, because right here it's set at 300. That's why it's not going all the way across the screen. However, you also have the ability, let's say you didn't know what the width was, but you knew that you wanted it to go across the screen. You would type window.width. And that would also take care of the width of that text label. Okay, so that was, oops, wrong side. That was here on line 23. I changed the 300. You could make it a specific number because you do know that the width is 1,018. You can also make it window.width, and it will automatically take care of that for you. Okay, who's been able to center a button so far? All right, Jackson, tell me how, or tell me one of the places you made a change. So you added a line, or you okay. So and obviously it's is it working for you? Okay. So if you look on line 29, notice how you already have no button text.x equals no button.x. If you change that .x to .center underscore x, that's going to take care of it because it's going to center your text with the button. And the reason by adding it that it's working for Jackson is just because that's the last thing there. So it ran through that and left that there. So that means that you also have to do that with the on line 34. Okay, this one has a little different error. How did we fix this one? Line 34. Right now you have yes button, text center X equals 800. If it worked for the no button, don't you think that same code would work for the Y button? Or I shouldn't say the yes button. Yeah. So I'm going to go ahead. I'm actually going to copy the code from line 39, and I'm going to paste it over the code in line 34, and I'm going to change where it says no to yes. And then I should have my text aligned along the top so that's centered on the whole window, and each of the buttons has the text centered on the button itself. Okay, did everybody get that now? Theirs is working. Okay, so make sure, please, that you hit submit. And then I want to go over something with you guys before I go into the animation instruction. Okay, so I know that we've had a few people that have had some absences, some extended absences, some just a day or two here and there for whatever reason. What I want to make sure that you guys are doing is this. When you're absent, remember that you have a certain amount of time that you have that you can make stuff up. Because, for instance, last week, the day before the quiz or day before the test, I went over all the previous quizzes, giving you guys opportunities to answer, yet there were people that were not done. But some of those quizzes were 3 weeks old. I can't wait and not give answers. Okay, so if you did it after that time, you're not getting credit for it because I gave the answers that day during class. You have got to be taking care of your assignments in a timely manner. And again, I realize that with some extended absences, you get more time, but we've got to get started on those, okay? Number 2, your phones, when you come in, they are supposed to be in the wall pocket so that they are not a distraction to you. And when you are done with your work, you can get them from the wall pocket, okay? 3, if you don't finish something during class time, unless I tell you that we're going to continue it the next day, which every once in a while we do, if I feel like it just took way too long and you need more help, I'm going to continue it the next day. But most of the time you need to finish those little exercises for homework to get those done. With that being said, remember last semester I gave you guys the 1 day late, 2 days late, 3 days late. After that, I'm not accepting it. Okay? And again, extended absences, I realize that's an issue, okay, that has a different guideline for it. But if you guys don't finish it in class, you've got to do it for homework. And what I have done is I have made, I'm calling them a bribe bag because it is a bribe. I am making a bribe bag. It is full of candy, a soda, and a small gift card. And at the end of the 6 weeks, so that's 3 weeks, there will be a drawing for who gets it. And how you get entered is each time you submit your work on time, that means that you are done by the end of the day, then your name gets entered for that. So the more times you finish something on time, the more times it's going to be entered. And when I say entered, what I want you guys to realize, each day you have a warm-up that you are supposed to do in order to get that full credit for doing your work. I go over demos with you that you are supposed to follow along with so that you have some things to look back at. If you get stuck on assignments, you can say, oh yeah, we went over that. Let me go refer back to this and see how I did it there, okay? You're supposed to have that. Some days we have planning things, you're supposed to have that. And whatever instructional practice and or code writing goes with that day, okay? You don't get to pick one out of those 4 or 5 things and say, okay, I'm done with that. That's not how it works. So make sure that you are finishing everything. Also, you put turning in stuff that's halfway done or code from another project hoping that I'm going to not pay attention. That doesn't work either, okay? And I'm not saying that something could be wrong because I'm not expecting everything to be perfect, but it can't be so vastly wrong that nothing works whatsoever, okay? Because if it is, then you need to ask for help. Does anybody have any questions? Okay, so let's go ahead and get started. You do need your Canvas ePortfolio open because we've got a few vocab terms that we are going to enter today. Okay, so I want to remind you that in order to draw images to a window in TechSmart, you have to use sprites from the TS app library, from their graphic library. So starting today, we're going to learn how to make those images animate or move on the screen. Okay? So you have animation, frame, sprite sheet, speed, image animation rate on your vocab that you're going to do. Okay? All right. So if you look at this image of a puffin flying, you'll see that no part of the computer is actually moving when we look at this. So why does it look like it's moving? Why do you think? Say it again. It is. It's animated. Yeah. So how many of you have ever made animations? Anyone? Okay. How do you make, like, what's something, a key term or key point of animation? Frames. Yes. Frames are like moments in time. Okay. And the reason that this is moving is because the image changes over time. So it's in one frame it looks this way, in another frame it's this way, another frame it's this way, et cetera, et cetera. Let's go ahead and hang on, I want to see something real quick. I want you to go to somewhere that's blocked, of course. Hang on. I'm going to do it the old-fashioned way. Let's see. I'm going to pass out some sticky notes. You guys need let's say 10 stickies. They don't have to all be the same color, so take 10 and pass down so that pass down so that the next person can get 10 as well. Okay? So we'll have to go around this way. As soon as you get your 10, actually you might even just walk across the room because they are. Turn off of there. All right. So, on the first post-it, you're going to draw an image. Now, you can draw something as simple as, okay, now first, when I say draw an image, some of you might be like really good artists and say, oh, I'm going to do, you know, this, 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 and this. We don't have time for all that, okay? So something fairly simple. You could do a stick figure. but I want you to think about the fact that you will have, you could even do a ball bouncing across, but you need to plan it for 10 frames, okay? So you could have a stick figure waving, you could have a ball bouncing, smushing on the ground, something like that. So, once you get the first one drawn, obviously you know that you have to make a second and a third and a fourth that has a little bit of a change, so that as you flip through it, you can actually see the change, okay? So I'm going to give you guys a few minutes to do that. All right, now that you have shared with someone, I want you to put this in your ePortfolio. Animation, it is rapid changes that the human eye perceives as motion. Rapid change that the human eye perceives as motion. All animation is really just an illusion. We are tricking our eyes and our brains into thinking that something is moving by changing it very fast. This works just like a flip book if most of the image is the same, but a few things are slightly different each time. Our brain interprets this as the changed parts have moved. So if you look here, you can see the example of the images that were used to create the flapping puffin. All 30 of these images repeat every second because this happens so fast, you stop seeing the individual images and see the movement instead. This is the same technique used in animated movies. Okay, live action movies do this too because a movie camera records a series of frames or a series of frames or still images like photos and plays them back at 24 to 30 frames per second, depending on where you're looking, okay? So, we're going to explore a program. You're going to switch to the code view and look at Part 2, Dragonflight. First thing I want you to do is go ahead and play the program so that you can see what it does. Okay, so we have a dragon that flies across the screen, flapping its, I don't know, arms or something while moving up and down, and then it stops. So what I want you to do, looking through the code, you can see different things such as scale, animation rate, X speed, Y speed. You can see where they're got some conditions about center Y, center speed, center X, center speed, etc. So go ahead, I want you to look and try to do these three things. Change how fast the dragon moves across the screen. Then change how fast the dragon's wings flap. And finally, when the dragon stops moving right, also make it stop moving up and down. See if you can do that. All right. So if you look, the dragon's movements, the controls start with setting speeds. Did you find what lines the starting speeds are set on? Let's look at line 22 and 23. Do you see dragon.x speed, dragon.y speed? And they start off at 50. Well, what if we change that to 150? And change it to 20 so that you can see the difference between those speeds. So 150 moved them across the screen much faster than 50 and the 20 that I changed it to. Now, the animation rate is on line 21, and it is set at 20. So if I increase that to 100, now we have his up and down movement and his wing movement, or his wing flap, much faster. If you wanted to make it slower, you'd have to decrease it from that initial 20. Now, when you make it too slow, it's almost like you can see, well, you can see every single image if you make it too slow. So if I slowed that down to a 2, you can literally see every image and how the tail moves with certain movements of the wings. Okay, so that's with the animation rate on line 21. It was originally set at 20. I have tried moving it faster as well as slower. Now, what do you think a negative y speed does? If I change it from a 20 to a negative 20, whoops, that's not a negative. What do you think that does? Well, so if I get, what is y? Is y left to right or up and down? Up and down. So if we look at this initially, the movement goes up and down like a cycle. Okay. And when it gets all the way over to the right side is where it stops. Well, I shouldn't say it stops. It can't move any further over to the right is what I'm saying. So it's just stopping there. Okay, so if I set that to a negative, he's moving up. Now, he does have to move down because there's a cycle, but he is moving up first before he can go down. Because there's so much up and down, that's kind of hard to see, but that's what it's doing. Okay. Okay. Let me go back to the slides. All right, so frame. Here is another vocab to add. One still image within an animation, which usually is one iteration of a loop. One still image within an animation, usually one iteration of a loop. So a frame is one image from an animation. By itself, we can't tell what is moving. The movement comes from what changes between frames, not what is in the frame itself. So if we're referring back to your flip book, what would one frame be in the flip book? Yeah, one sticky note, okay? All right, so here you have a visualization of that flying dragon. In a program, each frame is one repetition or iteration of the main loop. Each time the loop repeats, the program draws a new picture. If we want to animate it, we have to make sure that the next time we loop, that picture is slightly different than the previous time. So what part of the code actually draws the picture in our main loop? If you're looking at that code again, what part of the code actually draws the picture in our main loop? What do you think? Say that again. Well, add object does put it on the window, but in the main loop. So look down here in the section called main loop. In that loop, what do you think is drawing the picture in our there? Say it one more time. No. Good guess, though. Any other guesses? Say that again. Nope, not the if statements. Remember, those are conditionals. Yeah, finish the frame. Window.finish frame. Okay, that's what's actually drawing it in our main loop. Okay. Oops. All right, so you have two animations here on the screen. Excuse me. How are these different? Okay, yeah, one is kind of a still image that just moves across the screen, right? It's changing its position, but otherwise the image stays the same. The second puffin is changing its image, but its position on the screen is staying the same. Okay? Now, obviously, you can put both of those together, right? But a lot of times what we see is something, just a still image moving. All right, now, Sprite Sheets. It's an image designed to be broken apart and used as an animation. If it's an emergency, you can go. You leave your phone. Okay. All right, so Sprite Sheets are created especially to be animated. They're basically an entire flip book contained in a single image. So any Sprite Sheet can be divided into some number of rectangular images that are all exactly the same size. The animation is created by repeatedly switching between those different image rectangles. So here you've got a few other examples of Sprite Sheets. There are many different Sprite Sheets in the asset library for you to use. including characters, vehicles, and special effects. You can recognize them because they contain multiple small images instead of one big one, and usually end with the word sheet. Go ahead, take a minute to go search the asset library for Sprite Sheets. So remember, if you go to Project, add image, that's where you're going to find all of your assets. And you can see too, right off the bat, the Ada idle sheet and air child. So there's quite a few of them in there. Not as many, obviously, as just single sprites, but you do have a few sprite sheets. Okay? Now, the TechSmart platform and TS app automatically know how to convert these particular images into animations. Outside of the platform, you would need to give the code more information, such as how many rows and columns of images are on that sprite sheet. Okay? So, image animation rate, and this is important. This is an attribute that controls how fast these images from a sprite sheet change. Now, if the number is, actually, let me rephrase that. To make it seem more flawless and more cohesive, do you think you would have a higher or a lower animation rate? Higher, yeah. The higher, and within reason, because if you make it too high, it may flutter so fast that you don't see anything either, or anything recognizable. But if you have a higher animation rate, it is going to be a smoother transition from one to the other. And I would go ahead and add the general syntax fictor, the sprite.imageAnimationRate equals integer. So you would have an integer to give the animation rate. This number represents how many different images from the sprite sheet the program will try to show in 1 second. All right, then we have speed. These attributes that control how fast and what direction an object moves on the screen. So speed is used to control movement-based animation. X speed controls left to right or horizontal motion. Y speed controls your up or down or your vertical motion. The number represents how many pixels the sprite will move in 1 second. A negative number will still move, but it moves in the opposite direction. In other words, positive values add to the sprite's coordinate and negative values subtract from the sprite's coordinate. If we add to our y coordinate, use a positive speed, what direction will the sprite move? If we are adding to our y coordinate, which direction do you think it will move? Yeah, up. Yeah, which one though? Up or down? Because where is the 0 coordinates? Where is 0, 0? It's different than math. Top left. Okay, so if you're adding to the y coordinate, it's going to go down, because down is a higher number. Okay. In coding, y increases as you move down, so a positive y speed means that a sprite will move downwards on the screen. As you might have guessed, because speed involves adding or subtracting from the sprite's position, we could do this manually with plus equals or minus equals. However, doing so will create code that will run faster or slower depending on your computer speed. Using the speed values instead will let TS app run some background code that attempts to compensate for this difference. Okay, so as you know, there's always different ways to do things. All right, here are some examples. Okay, the conditionals are checking where the hawk is on the screen. Specifically, if it's between 100 and 350. And then it changes if it is. All right, so we are going to be working on manipulating the speed to change direction and how we can make scrolling games that appear to go on forever. Okay? Think about some programs that use animation and be ready to give an example of an animation in a game or app. And think about how it uses movement, speed, image animation rate, or both. Okay? Go ahead and log out, and we will continue tomorrow with the 2 instruction practices. We'll start with those first.